Good morning. So in this video, I'm going to discuss humidity and relative humidity. So this topic will be included in the final exam. Let me share you the PowerPoint. Okay. So humidity and relative humidity. So several unit operation or equipment in chemical engineering uses this concept. So you're going to encounter this in unit operation courses, humidity and relative humidity. Basically, humidity is the amount of water uh, in a given amount of air. And then relative humidity is the percentage. Okay? This refers to the percentage that the air is saturated. So we have some definition or equation that defines humidity and relative humidity. Okay. So first, humidity. So humidity or H is simply defined as kilogram of water per kilogram of dry air. So when you say dry air, this means it only contains oxygen and nitrogen, and it contains no amount of water. So this is the definition of humidity: kilogram of water per kilogram dry air. So mathematically, generally, we can calculate humidity if you know the partial pressure of water in the air. Okay, so this is uh, pH2O all over P. P right here is the total pressure or the ambient pressure, no, the atmospheric pressure. This P right here minus pH2O. pH2O is the partial pressure of water. Let me annotate this slide. Okay. Patulong nga. Ayos yung ulit ng ano. Pabuunod nga ito at pasaksak ulit. Ito, itong wire na ito. Huwag yung camera ha. Dito, ito. Yan. Okay. So, pH2O is the partial pressure of water in air. while P is the atmospheric pressure. The total pressure of air. No? So this could also mean the total pressure of air. Usually in a problem, if P is not given, the default value is 1 atmosphere. Okay. So basically this equation pH2O divided by P minus pH2O, basically this is equal to pH2O divided by P dry air. Okay, this one. This is equivalent to pH2O divided by P dry air. And then if you're going to assume that the system is ideal, it follows the ideal gas equation, that is equivalent to number of moles of water divided by number of moles of uh, air, dry air. No? So pH2O divided by P minus pH2O is the same as pH2O divided by P dry air. Kasi when you remove water from air, this is air, you're going to have dry air. So that's why these two equations are the same. And then, so what I'm trying to say is if the system follows the ideal gas equation, most of the time, no, most of the time, air system follows the ideal gas equation because the pressure that these issues in the industry is quite low, almost around 1 atmosphere. So at that pressure, the air is ideal. Ano? So this is the same as ano, number of moles of water, number of moles of dry air. Okay? When you have ano, ideal gas system. Okay? So why is that so? Because ideal gas equation is PB is equals to nRT. So what will happen if you're going to substitute the equation for pH2O? That would be nRT over B. No, that would be N water uh, times R gas constant times the temperature divided by the volume, and then denominator you have N dry air gas, the same gas constant. They are on the same container, so they have the same temperature, and then they have the same volume. You know? So as you can see, all the other variable will cancel out. So if your system is an ideal gas, NH2O divided by N dry air is the same as pH2O divided by P dry air. So thinking in the same context, NH2O divided by N dry air. So when you multiply NH2O with 18, right here, when you multiply it with 18, this is the molar mass of water. You're going to get the mass of water, the kilogram of water. And then if you're going to multiply dry air with 29, you're going to get the kilogram of dry air. So that's the justification of this equation. So you really need to remember, you really need to memorize this equation. You know, humidity is equals to 18 divided by 29 times pH2O divided by P minus pH2O. Okay, so next, let's take a look at relative humidity or RH. So when you say percent relative humidity, you simply divide the partial pressure, pH2O, with the saturated pressure of water at that temperature. So these are the two symbols of saturated water. You can commonly see this symbol in different references. So in this definition of percent relative humidity, P P star H2O, and it's just the same as P saturated H2O. Just the same. This is these two variables are just saturated pressure of water at a specific temperature. So you can get this P star H2O and PSH2O using steam table. I'm going to send you a scanned copy of the steam table from Banes. Pero if you have your handbook, you can use the steam table in the handbook. Probably you could also use the internet to find the P star H2O or the PSH2O. So RH is simply 100% times PH2O divided by P star H2O. So usually, siyempre, PH2O is usually less than P star H2O. So your percentage would range from 0 to 100%. When you have an RH of 100%, uh, that's what we call saturated air. No, it means it contains the maximum amount of water. So that's saturated air. If RH or percent RH is equals to 100%, we have saturated air. Okay, so if you have the handbook, you can use the handbook to find P star H2O or PSH2O, or I'm going to send you a scan uh, theme table. I hope you can read it. Okay, so you can find on the handbook, you can find this on chapter 2, page 413 to 415. No? So ang title niya is Thermodynamics of Water. If you have the 9th edition, so just try to look at around this page 400, page 400 on chapter 2. And then the title of the table is Thermodynamics of Water. So right on this column, you have the temperature. I think it's in Kelvin. Tapos right here, you have the P star H2O. I think it's in megapascal. So just read the corresponding pressure for the corresponding temperature. So again, this is the pressure column in this steam table is your saturated pressure, PSH2O. PSH2O. So let's try to solve some problem, illustrative problem. So this is from Jean Copley's. The air in a room is at 26.7 degrees Celsius or 80 degrees Fahrenheit. And its pressure is 101.325 kilopascal. So this is your P, no? And contains water vapor with a partial pressure P sub A of 2.76 kilopascal. So you need to calculate the parameter. You're going to calculate first the humidity, and then second the percentage relative humidity. So just try to remember the formula. It's quite easy, no? If you memorize the equation. Okay. So for humidity, I've already explained this. Ano? This is simply equal to 18. I'm trying to solve letter A, humidity, divided by 29 times P sub pH2O divided by P, that's the atmospheric pressure or the total pressure, minus pH2O. So just substitute the given. It would be 18 divided by 29 times 2.76 kilopascal divided by 101.325 kilopascal minus 2.76 kilopascal. So, ito muna, ano? Ano yung gawin niya? So, just paabot na ng calculator ko. Layo dito. Okay. So I'm getting 0.0174. No, 0.0174. So the unit is ano, kilogram water per kilogram dry air. Okay. Okay, so let's try to solve percentage relative humidity. Letter C. I'm going to clear this. So for percentage relative humidity, you need to use the steam table, you know, and to find PS H2O or P star H2O. Because if you still remember, relative humidity equation is P H2O divided by P star H2O. So you need to use the ano, no, to use the steam table. So try to look for 80 degrees Fahrenheit. Sakto yun, no? So at 80 degrees Fahrenheit, should be able to find that the P star H2O of water is around 3.5 kilopascal. So after finding this, you just substitute it right here, times 100%. Times 100%. So just substitute it in the equation. So RH is equal to pH2O 2.76 kilopascal divided by 3.5 kilopascal. So times 100%, we have 78.86. Ano mga? Around 79%. Around 79%. So the percentage relative humidity is 79%. Okay? So I hope you get this quite simple concepts. The important thing is you need to memorize, you know, the definition or the formula in solving this problem. Okay, so on the next video, I'm going to talk about the psychrometric chart. And then we'll solve an application problem. That would be the third video. And then I'm going to push your final exam. So see you in the next video.